Ladies and gentlemen, in this video, we are going to introduce to you the idea of significant figures. If you have already taken Physics 11 in this school, you would have studied this already, so this is going to be a really quick overview. In fact, you can probably just press stop right now. But for everyone else, it is important to know that not all numbers count. Not all digits in a number actually have a meaning. So I'm going to show you a few different examples. We will write formal rules to this tomorrow. I should say you will come up with formal rules to this tomorrow. But I'd like to see if you can see the patterns forming here. Question number one. If you have a number like 321, all three of these numbers are significant. So how many significant figures do you have? Well, you have three. The 3, the 2, and the 1 are all significant. They all hold a value. Same with example number 2. If you have a number like 206, you still have 3 sig figs. Sig figs is significant figures. The 2, the 0, and the 6 are all significant. So, in a question like number 3, you have a number like 4,000. In that number 4,000, there is only one sig fig. Just this 4 is significant. Those zeros don't have any meaning because this number can be written 4 times 10 to the 3 and it would still be 4,000. So those zeros, they're called trailing zeros, have no meaning. They're not significant. But if you put a decimal place in there, like in question number 4, that decimal place then shows you that all of those zeros are significant. So the 4 is significant, that, and that 0 are all significant. So this number actually has 5 sig figs. Everything in there is significant. So zeros in between numbers and decimals count, and this 0 is called a trailing 0 after decimal. It counts. It's significant. Back to number 5. Nothing fancy here. The 0 is in the middle of numbers that count, so this also has 5 sig figs. Question number 6. The numbers 316 all count, but this 0 does not count. So a leading 0 before a decimal does not count. It does not have any meaning. So this simply has 3 sig figs. And lastly, number 7, it relates to number 6. Leading zeros do not count. This simply has 3 sig figs because this number can be written as 3.16 times 10 to the negative 3. Those zeros are not included in that scientific notation number. So tomorrow in class, you will come up with rules that talk about zeros after a number that counts, zeros in between numbers that counts, zeros after decimal place, and zeros before decimal place. Those are the rules that we're going to try to get you thinking of. What I'd like you to do is try these. Okay? Spend 45 seconds, rip through them. Okay? Press pause, and I'm going to show you the answers right now. Okay? There's the answers. We'll go over these things in class for sure, but hopefully you did these things fine. So moving on. Once you can count sig figs, you're basically going to be doing math with them. Adding and subtracting and multiplying and dividing. Nothing fancy. We don't do a lot of adding and subtracting in Chem 11, as funny as that sounds, but here's the rule for it, and it basically goes back to elementary school. When you're adding or subtracting numbers with decimal places, you can't add or subtract decimal places that don't exist. So if you have to add 2.106 to 13.4, you can't add the 0 and the 6 there because there are no decimal places. So this number added together is 15.5. You're actually using sig fig rules there. So when you add and subtract, you have to round your answer to the least number of decimal places. You're not even counting sig figs in these questions. You're just rounding your answer to the least number of decimal places. Period. So a number like, I get a number of 4.5733. I need to round this to the least number of decimal places. Here there are 4 decimal places, there are 2 decimal places, so my answer just needs 2 decimal places. So my final answer is 4424.57. That's it. Okay. This is a special example. I'll do this one with the group tomorrow. The most popular thing we do in Chem 11 is multiply and divide. So here you have to count sig figs, and the rule is you round your number to the least amount of sig figs. So if you have a number 62.1 times 88, you get 5464.8. Now you got to count sig figs. This whole number has 3 sig figs, that has 2 sig figs. So we have to round this number to 2 sig figs. So it's going to be 5.5 times 10 to the 3. Or you can put 55,000, whatever works for you. It seems silly to do, but that's how it should be in real life. You have to round to the least number of significant figures. So this next question, 101.3 times 2.1 exponent 3 is 212,730. We have to count sig figs. This number has 4 sig figs in total. This number has 2. So our number needs to be to 2 sig figs, which is 21, whatever that number is, 210,000, or 2.1 times 10 to the 5. You always round to the least number of sig figs. We'll try those two. We'll also be doing these practice questions tomorrow and a little activity to get you used to sig figs. Should be pretty straightforward. See you tomorrow.